KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, now we are going to discuss about lens maker's formula. We are also going to discuss about lens formula. So in our last class, we studied the refraction at a single curved surface. So in our last class, I told you thin lens or lens is the combination of two spherical surfaces, two spherical or two curved surfaces, right? But I am not saying that when there is only two curved surfaces, it is lens. No, I am not saying like that. But here we are going to study about a lens. Now we are going to study about refraction through a lens which has two curved surfaces as shown in the figure, right? Suppose there is only one curved surface and one flat surface, means that is also lens, and this side flat and that side curved means that is also lens, okay? But here we are going to study about the lens which has two curved surfaces, okay? Right. See this, ma? First you try to understand the pictures. So what I drew here. So this is the picture. Here we have two curved surfaces, right? Two spherical surfaces, and it is the object, it is the object distance, it is the optic center. So it is the incident ray which is going to incident on the central axis of a spherical lens, okay? And this is the refracted ray, and it is also one of the ray. So it comes from object in this manner, which is along the principal axis, right? So these two rays will meet at meet at I. So I means image, okay? Image formation, right? So at I, these two rays are going to meet. So here you can see the image of the object. This is the image distance. This is the image distance, and with these directions you can understand how the light is going, from where to where light travels, okay? Right. Now what I am saying is, this is the lens. So how we made this lens, how we designed this lens, that we are going to see now, okay? Right. By seeing that you can understand it is the combination of two different curved surfaces, two different spherical surfaces. Two different means I am not talking about two different radius of curvatures. It may or may not, but this is one curved surface, it is another curved surface. So this lens is the combination of two curved surfaces, okay? Right. So first we are going to study the refraction for this curved surface, and then we are going to study the refraction for this curved surface. Then whatever the mathematical relations we are going to obtain, those two mathematical equations we are going to add, because this lens is the combination of two curved surfaces, curved surface 1 and curved surface 2. Now you come to see these two pictures. So it is the curved surface here, and it is the curved surface here. See this. So it is the incident ray, incident light from object. It is the normal at this point of incidence. It is the principal axis. It is the curved surface, right? It is the angle of incidence and angle of refraction. Okay. So here also we have two rays, same picture, but we are going to observe the refraction here only due to this curved surface 1. Okay, right. So when the light comes from object and it is going to meet two light rays, right? It is the one incident, it is the one light ray 1 and light ray 2. For sake of observation, we are taking two light rays. As I mentioned 2 or 3 times earlier, for the formation of image, there are hundreds and thousand rays are going to meet. For our convenience, for our comfort, for our sake of understanding, we took two light rays. Okay, right. So this is the position of the image due to the first curved surface. It is very important for us to understand. It is the position of the image due to the first curved surface. Okay, right. So it is the center of curvature 1. Due to this curved surface, this is the center of curvature. So I already told you, center of curvature is an image, is a point. Center of curvature is a center of an imaginary sphere in which this curved part is a part. In this curved part is a part. Okay, right. So it is the center of curvature 1, and automatically it is the radius of curvature. It is the refractive index of one medium. It is the refractive index of another medium. See this. Okay, this is the second curved surface, right? So it is the position of the image. It is the position of the image due to the first curved surface. Due to the first curved surface, right? This image acts as object to the second curved surface. This image acts as object to the second curved surface. This is the final image. This is the image because of two curved surfaces. This is the image because of two curved surfaces. Okay, right. So here also we need normal to decide angle of incidence and angle of refraction, right? So for second curved surface, here it is like angle of incidence and it is the angle of refraction. So this is radius of curvature for second curved surface. So I request you, please try to understand this picture and these two pictures. Okay, here only almost we understood everything what I am going to explain here in this class. Okay, right. So in this class our discussion is lens maker's formula. Lens maker's formula. While designing lens, right, by having a sight problem, okay, we are going to meet eye doctor. He will advise lens either convex or concave, depends upon the type of defect. Okay, so there itself how much focal length we need. Okay, so there itself we are getting the importance of designing lens, right? So this class has great importance for us in our daily life. Okay, so here our discussion is what is lens maker's formula, the derivation of lens maker's formula, right? So this is the picture. I already explained you what is what, and this picture relates to these two pictures, right? It is the first curved surface and it is the second curved surface. Okay, right. Now I am going to explain theory. It is like a heading. It is what a geometry of image formation by a double convex lens. Okay, right. See this. The image formation can be seen in terms of two steps. As I explained earlier, the first refracting surface forms the image I1 of the object O. The image I1 acts as a virtual object for the second surface. See here, that forms the image here, right? So at first interface ABC, we get, in our previous class we derived a formula for image formation, that is N2 by V minus N1 by U is equal to N2 minus N1 by R, right? That is the relation which relates image distance, object distance, refractive indices of two media, and then radius of curvature. radius of curvature, right? So that is n2 by v minus n1 by u is equal to n2 minus n1 by r. From that relation here, so that relation we are applying for first curved surface, then we are getting this one. That is what? n1 by OB plus n2 by BI1 is equal to n2 minus n1 by BC1. n2 minus n1 by BC1. Okay. Just we are applying the image formation at first curved surface, then we are getting this mathematical relation. It is equation number 1. Next, applying similar procedure at second interface ADC. At second interface ADC, same formula, that is what? Image formation formula, that is n2 by v minus n1 by u is equal to n2 minus n1 by r. We are applying here. Here means at second interface ADC. Then we are getting this relation minus n2 by di1 plus n1 by di is equal to n2 minus n1 by dc2. Okay. It is like equation number 2. It is the mathematical relation we are getting when we applied image formation relation to the first curved surface. This is the mathematical relation we are getting when we applied image formation relation to the second surface. But our lens is the combination of two curved surfaces. So curved surface 1 or curved surface 2. Okay, right. So that's why we have to join, we have to add these two equations to get this one, right? And one more small assumption is here for thin lens. So this topic we are deriving, this topic, in this topic our consideration is thin lens, not thick lens. So for thin lens you can write it as BI1 is equal to DI1. BI1 is equal to DI1. So now we are going to add these two equations to get the equation for this combination of two curved surfaces. Okay. So just mathematically you have to add these two, then we are getting n1 by OB plus n1 by DI. Okay. n1 by DI is equal to n2 minus n1 into 1 by BC1 plus 1 by DC2. 1 by DC2. It is like equation number 3. It is like equation number 3. So this equation represents the combination of two curved surfaces. That is what? Thin lens. Thin lens. Okay, right. We have different positions of object. That is not in our hands. Wherever you want, you can keep the object. Suppose for example, between focus and optic center, between focus and center of curvature. So beyond the center of curvature at infinity. So the position of the object is not our wish. So wherever we require, wherever the object is, that you have to focus to see the image. Suppose for example, if the object is at infinity, if the object is at infinity, then OB tends to infinity. So in place of OB you can write infinity, then DI is equal to F. Here itself you have to know the importance, I mean one of the situation when image is formed. So before 2-3 classes I told you, when suppose in case of paraxial rays, so when the object is at infinity, we considered the rays which are coming from the object are parallel to the principal axis. Then after completion of refraction, all these rays will pass, will meet at a point. That point is called as focus. So from that definition, from that information, you can write DI is equal to F, right? So we are substituting these two values here. So 1 by infinity is equal to 0. So that n1 by f is equal to n2 minus n1 into, this is as it is, 1 by bc1 plus 1 by dc2. It is like equation number 4. Next, now we are applying Cartesian sign convention. Already you know what is Cartesian sign convention, right? If the distances are measured in the direction of incident ray, should be taken as positive. If the distances are measured opposite to the direction of incident ray, should be taken as negative. But all the distances should be measured from optic center onwards. Next, distances measured vertically upward from principal axis are positive. Distances measured vertically downward to the principal axis are negative, right? So this is all about sign convention that we are applying here. So that BC1 is equal to plus R1 and DC2 is equal to minus R2. So that 1 by F is equal to, right? So the whole equation is dividing with N1. Then here 1 by F is equal to, here N2 by N1 will come, minus N1 by N1 means it will be 1 into 1 by R1 minus 1 by R2. Okay. So in place of N2 by N1 we are writing N21. Refractive index of second medium with respect to first medium is equal to N2 by N1. The above is known as lens maker's formula. Lens maker's formula. So whenever you are going to meet eye specialist, because of having some sight problem, he used to advise some lens for you, right? Afterwards you are going to meet optical shop, okay? So there he will design lens. So he needs this formula, that is 1 by F is equal to N21 minus 1 into 1 by R1 minus 1 by R2. As usual, our two different mediums when we are using spectacles are glass and air, right? So those are the two mediums. For those two mediums we know the refractive index values, right? So based on that he will design the lens and he will give us, right? See here, it is useful to design lenses of desired focal length using surfaces of suitable radii of curvature, right? So here one is R1, another one is R2, okay? So one is R1, another one is R2, okay? Sorry, whether he focused or not there. Okay, okay, sir. Right. So here desired focal length using surfaces of suitable radii of curvature, right? In case of concave lens, see this. In case of concave lens, right? R1 is negative, R2 is positive, and therefore F is negative. In case of concave lens, R1 is negative, R2 is positive, and therefore F is negative, right? So that what can we say here from equations 3 and 4? From equations 3 and 4 we get this. So it is equation 3, it is equation 4. See this ma. N1 by OB plus N1 by DI is equal to N1 by F. So it is equation number 3, it is equation number 4, right? So right hand side is same, so that mathematically you can equate left hand side. So N1 by F is equal to N1 by OB plus N1 by DI, right? Is it okay? Next, in case of thin lens approximation, B and D both close to the optic center of the lens, right? B and D both close to the optical center of the lens, okay? Applying sign convention. So here we have to apply the sign convention again. Then BO is equal to minus U, DI is equal to plus V, we get, right? So by applying sign convention you will get it as 1 by V minus 1 by U is equal to 1 by F. So this is in case of thin lens, right? The above is familiar thin lens formula. The above is the familiar thin lens formula, right? Okay. See this. The thin lens formula is valid for both convex as well as concave lenses, right? So while deriving whatever the lens you used, either convex lens or concave lens, but generally it is applicable, it is valid for both convex as well as concave lenses, and for both real and virtual images, right? So I already mentioned in our previous classes, real image is formed because of actual meeting of refracted rays or reflected rays. Virtual image is formed because of appear to meet of refracted rays or reflected rays. That is the difference between real image and virtual image. You can also say that real image is possible to catch on the screen, but virtual image you cannot catch on the screen, but you can see. You can see, right? So afterwards, sign convention for real image and virtual image, we need not remember separately whether it is positive or negative. So just if you apply Cartesian sign convention, what I already told you, even in this class also I told you what is Cartesian sign convention, right? That is what the distances measured in the direction of incident ray should be taken as positive. The distances measured opposite to the direction of incident ray should be taken as negative. Okay. So at the same time, all the distances should be measured from optic center onwards. Next, the distances measured vertically upward from principal axis should be taken as positive, and the distances measured vertically downward from the principal axis should be taken as negative, right? So it is about Cartesian sign convention, right? So that you can apply anywhere to get either positive or negative for one particular quantity, whether it is image distance or object distance or radius of curvature or focal length, whatever it may be. Okay, right. Next, it is worth mention that two foci, right? Two foci. I mean here we have two curved surfaces now. So one this side and another one this side. Okay, so that's why we have two radius of curvature and two focus. So like f and f dash of a double convex or concave lens. Double convex or concave lens are equidistant from the optic center. If you see the picture, you can understand. Equidistant from the optic center, right? The focus on the side of the source of light. The focus on the side of the source of light, that is called as first focal point. First focal point, and the other one is called as second focal point. Second focal point. Okay, right. So now I explained you what is lens maker's formula and what is lens formula, right? So as I told already, when we have some vision problems, when you are not able to see the distant object, when you are not able to see the nearby objects, then we are going to meet eye specialist. Okay, so the doctor will check what is the problem and how much is it, because the measurement is also important now. Afterwards, he used to write some information on a paper, prescription paper, that he will give you. Then you are going to meet optical shop, right? There he will, by seeing that prescription paper, he start to design the lens, right? So there he need lens maker's formula based on the quantity of problem or the intensity of problem what you have regarding your eye, right? So what is lens maker's formula and how to design, I mean how to derive lens maker's formula, right? So that we discussed in this class. So first, whatever the pictures I showed you, first picture is the combination of two curved surfaces, and because of two curved surfaces, because of first curved surfaces, what is the effect, and because of the second curved surface, what is the effect. First we have to discuss, we have to understand separately. After that we are going to join these two, because lens is the here in this class, lens is the combination of two curved surfaces, right? So because of the first curved surfaces, the image is I1, which is formed other side of the object, because here lens means the concept is refraction, right? So that image is I1. As usually we will get it, what is angle of incidence and what is angle of refraction, right? And you know what is radius of curvature, that is like R1. And two different mediums, one is the refractive index of N1, another one is the refractive index of N2. Now if you take the second curved surface, right? So there the refractive index, refractive index, one is N2, another one is N1, because here the light is going to travel generally from glass to air. So N1 is air and N2 is glass generally. If you want, you can change. Okay, right. Now, in case of second curved surface also, C2 is the center of curvature, R2 is the radius of curvature, and I2 is the angle of incidence, R2 is the angle of refraction, and that image I1, which is formed due to the first curved surface, acts as a object, acts as a virtual object for second curved surface. So the final image will be formed at I. The final image will be formed at I. At the same time, based on this picture, so one picture is belongs to first curved surface, another picture is belongs to second curved surface. You have to apply image formation formula. Image formation formula. Image formation formula is N2 by V minus N1 by U is equal to N2 minus N1 by R. Right? So by applying that formula at first curved surface, you will get it as N1 by OB plus N2 by BI1 is equal to N2 minus N1 by BC1. It is the first equation. Similarly, by applying image formation at second curved surface, or second interface, ADC, gives you minus N2 by DI1 plus N1 by DI is equal to N2 minus N1 by DC2. It is the second equation. A small approximation for thin lens, that is BI1 is equal to DI1. But whatever the equations, two equations we got, these two equations for two different curved surfaces, surface 1 and surface 2. But actually lens is the combination of two curved surfaces here. So that we have to add two equations mathematically. So by adding these two equations mathematically, we are getting the mathematical equation for the combination. So it is actually lens. Okay. So this is the equation, that is N1 by OB plus N1 by DI is equal to N2 minus N1 into 1 by BC1 plus 1 by DC2. It is like equation 3. Right. So the position of the object is not in our hands. Wherever you want, you can keep it, and whenever and where you want, there you can focus. Suppose for example, if the object is at infinity, when the object is at infinity, we are getting paraxial rays. So in case of paraxial rays, after completion of refraction, all the refracted rays will pass through the focus. So when object is at infinity, the di is equal to f. So these two things we have to substitute in equation 3. Then finally you are getting fourth equation, that is n1 by small f is equal to n2 minus n1 into 1 by bc1 plus 1 by dc2. It is like equation 4, right? Now we are going to apply sign convention, that is Cartesian sign convention. bc1 is equal to plus r1 and dc2 is equal to minus r2. After that, we are also going to divide the whole equation with n1 to change the shape just mathematically, right? The sign convention is from that, that is like what we have to follow to assign a sign, whether it is plus or minus, okay, because of having left side and right side. But this dividing of n1 is just mathematically. Then we are getting 1 by f is equal to n21 minus 1 into 1 by r1 minus 1 by r2. So here n21 is equal to n2 by n1, refractive index of second medium with respect to first medium, right? So this is the important lens maker's formula. So the above is known as lens maker's formula. It helps us, it is useful to design lenses of desired focal length using surfaces of suitable radii of curvature. In case of concave lens, so whatever we derived here, right, it is convex lens. So what we derived is for convex lens. Even for concave lens also the procedure is same, but r1 will become negative, r2 will become positive. Almost because of these two, the radius of curvature is negative. because of the situation. So, how we are deriving for convex lens? Similarly, we can derive for concave lens. In case of concave lens, R1 is minus, R2 is plus, and F is also minus. Then from equations 3 and 4, so what we had here, N1 by OB plus N1 by dA is equal to N1 by F, right? Next, in case of thin lens approximation, right? So, B and D both close to the optical center of the lens. Then by applying sign convention, so this is the approximation and the situation in case of thin lens, and by applying sign convention you can write and you can get it as 1 by V minus 1 by U is equal to 1 by F. So, this is familiar thin lens formula, thin lens formula. So, this thin lens formula is applicable for both convex and concave lens as well as real and virtual images, real and virtual images. It is worth mention that because of the two focus points, I mean two foci, F and F dash of a double convex or concave lens are equidistant from the optical center. The focus on the side of the source of light is called first focal point, the other is second focal point. So, this class is very important for us for 5 mark question or 3 mark question regarding board point of view. For NEET point of view, the formulas what we had in this class, one is lens maker's formula, another one is lens formula. These two formulas are very important for us while solving the problems related to this concept. Okay, right.